Hello everyone, myself Kusuma, studying in Sri Venkateshwara College of Engineering. Today we'll be discussing about CMOS logic to implement NAND, NOR and compound gates. So let's begin. What basically is CMOS logic? So a circuit that uses complementary pairs of P channel and N channel MOSFET is called CMOS, that is complementary MOS. CMOS logic ICs combine MOSFETs in various ways to implement the logic functions. The logic gates are the basic building blocks of all the digital circuits and the computers. These logic gates are implemented using the transistors called MOSFETs. A MOSFET transistor is a voltage control switch. The MOSFET acts as a switch and turns on or off depending on whether the voltage on is either high or low. So there are basically two types of the MOSFET, that is NMOS and the PMOS. The NMOS turns on when the voltage is high and off when the voltage is low. The PMOS on the other hand turns on whenever the voltage is low and goes off as the voltage goes high. So when two are used together to realize the two logic gates, they are called the CMOS, that is complementary MOS. The reason they are complementary is that NMOS and the PMOS work in a complementary fashion. So when all the NMOS switch turns on, the PMOS gets off and vice versa. So CMOS stands for complementary metal oxide semiconductor, and CMOS based logic gates uses complementary pairs of NMOS and the PMOS transistors. So when MOS transistors are used as logic gates, then they are used as a switch. In both NMOS and the PMOS transistor, the voltage applied between the gate and the source acts as a control voltage. So as you seen in this picture, this is a NMOS transistor where this is a gate, this is a drain and this is a source. So it gives rise to, when it is an open circuit, VGS is lesser than the VT. When it is a closed circuit, VGS is greater than the VT. So by controlling the gate to the source voltage, PMOS and NMOS transistor can be used as a switch, and they can be used to design a logic gates. So this is a NMOS transistor. Let us move on to the PMOS transistor. In the case of the PMOS transistor, this is a gate and this is a drain and this is a source. Whereas when it is an open circuit, VSG is lesser than the mod of VT. In the case of the closed circuit, VSG is greater than the mod of VT for PMOS transistor. So CMOS logic uses both NMOS and the PMOS transistors. So the PMOS transistors are used as pull-up network and NMOS transistors are used as pull-down network. So as you seen in this picture, this is a pull-up network and pull-down network. So pull-up network is connected to the VDD. So whereas pull-down network is connected to the ground. Pull-up network is connected to the PMOS, whereas pull-down network is NMOS transistor, and the output is connected to the Y. And because of that, the static power consumption of the CMOS based logic and logic circuit is very low compared to the logic gates, which is designed using only either NMOS or PMOS transistors. So moreover, CMOS based logic gates has higher noise margin compared to the NMOS and the PMOS based logic gates. Let us move on to the NAND gate. So this is the NAND gate structure. So whereas in the case of the NAND gate, the input may be a 2 and the output is 4. 2 power n, where 2 is the input, the final result will be a 4 combination. So in the case of the NAND gate, the PMOS transistors are connected in the parallel, where PMOS transistors are connected to the VDD. So in the case of the NMOS transistors are connected in the series, and the output is Y equals AB. So this is a truth table for NAND gate. So when the input is 0 0, the output is 1. When the input is 0 1, the output is 1. When the input is 1 0, output is 1. When the input is 1 1, output is 0, because AB bar, Y equals AB bar. For the two input NAND gate, if A and B are the inputs, then the output Y is A comma B whole bar. So in NMOS network, when we have AND operation between the two variables, then the two NMOS transistors will get connected in the series and the output will be complement of it. The PMOS network is dual of the NMOS network. In the NMOS network, if any transistors are connected in the series, then the PMOS network, the two PMOS transistors will get connected in the parallel. So this is the NOR gate. So where PMOS transistors are connected in the series and the PMOS transistors are connected to the VDD and NMOS transistors are connected in the parallel, and the output may be a plus B whole bar. So this is a truth table for the NOR gate. When the input is 0 0, the output may be a 1. When the input is 0 1, the output may be a 0, and when the input is 1 0, the output may be a 0, and when the input is 1 1, the output is 0. For the two input NOR gate, if A and B are the inputs, then its output is Y, A plus B whole bar. So in the NMOS network, whenever there is an OR operation between the two variables, then the two NMOS transistor will get connected in the parallel, and the output will be complement of it. The PMOS network will be a dual of the NMOS network. So therefore, in the PMOS network, the two PMOS transistors will get connected in the series. Let us move on to the compound gates. So what is compound gates? The compound gates are formed by combining the series and the parallel structures of the transistors. A compound gate performing a more complex logic function in a single stage of the logic is formed by using a combination of series and parallel switch structures. So for example, the derivation of the circuit for the function y equals a into b plus c into d is shown in the figure. So in the upcoming slide. So this function is sometimes called AND or invert 22 or AOI 22. So because it performs the NOR of a pair of two input ANDs. So for the NMOS pull down network, take the uninverted expression that is A into B plus C into D, indicating when all the output should be pulled to 0. And the AND expression that is A into B and C into D may be implemented by series connections of switches. So as shown in the figure A. So this is a figure A. So by De Morgan's law, this is the equivalent to interchanging and OR operations. So hence the transistors that appear in the series in the pull down network must appear in the parallel in the pull up network. So transistors that appear in the parallel in the pull down network must appear in the series in the pull up network. So this principle is called conduction complements and has already been used in the design of the NAND and NOR gates. So in the pull-up network, the parallel combination of A and B is placed in the series with the parallel combination of C and D. So this progression is evident in the figure C. So this is a figure C, and in the figure D. So this is a look. So this is a figure D, and putting the networks together yields the full schematic. That is figure E. The symbols are shown in the figure F. So the final symbols are shown in the figure F. So this AOI22 gate can be used as a two input inverting multiplexer by connecting C is equals to A as a select signal, then Y is equals to B if C is equals to 0, when Y is equals to D if C is equals to 1. So if you like this video, please do like, share and subscribe to my channel. Thank you.